Okay, Assalamualaikum. Hi everyone. Okay, hari ni, today we're gonna learn about the deflection of the reinforced concrete beam. Okay, deflection ni adalah benda selalu sinonim. So maksudnya, basically memang kita akan check the deflection of the beam ataupun slab. Okay, so deflection ni akan menyebabkan crack. Okay. So, macam biasa, at the end of this topic, students should able to, there are 3 points, okay? You guys should able to describe the importance of the checking deflection, of the beam and slab, okay? Then, you able to explain the procedure to check for deflection and also to calculate the deflection by limiting span to the depth ratio method. Okay, these 3 ni akan you guys obtain ataupun gain at the end of this chapter. Okay, so apa itu deflection? Okay, deflection adalah expression of the differential change in length between its upper and lower portion. Maksudnya ada perubahan daripada panjang antara atas dan juga bahagian bawah. Kira maksudnya, kalau kita cakap ni under bending load, kita akan ada kat sini, kita akan mengalami deflection. Okay. So, deflection of the beam at the maximum applied load. Kat sini, ditunjuk dekat figure ni. So, bila berlakunya deflection, apa yang terjadi sebenarnya? Bila berlakunya deflection, dia akan menyebabkan crack. Okay. Crack ni akan menyebabkan kita punya wall ataupun kita punya ceiling ataupun concrete floor punya slab. Kita bila crack je, kita akan menyebabkan ada lubang-lubang ataupun kita boleh provide ruang untuk air masuk. So maksudnya bila berlakunya crack akan ada lubang-lubang. Bila deflection ni akan menyebabkan crack. Okay? Bila crack ni akan mewujudkan satu rongga-rongga, ruang-ruang di mana air ataupun ataupun benda boleh masuk melaluinya dan boleh menyebabkan ketahanan dia tu berkurang. So dia akan mempercepatkan breakdown ataupun kerosakan the wall material itself. Okay, so maksudnya deflection ni sangat-sangat penting untuk kita check whether kita punya beam atau slab itu under control ataupun tidak. So, kat sini dia punya method of checking. Your code 2 have 2 alternative method. First is limiting the span to depth ratio, and the second is using the theoretical deflection calculation. Okay, so tapi in this module, we specific by using the span to depth method. Alright. Okay. First kali, procedure of the assessing deflection. First of all, we need to determine the basic of the L over D ratio. So, what is L? What is D? L is the span, length of span, and D is the depth. So, we need to find out the ratio between the span and also span to the depth. Okay, macam mana kita nak cari? Ada few step. First is by using the figure 7.2 for simple supported beam by determining the rho. Okay, kat sini rumusnya adalah kita nak cari nilai rho kat sini. Nilainya adalah 100 times with AS required. So, AS ni adalah area of steel yang required divide by B and D. Okay. Another method to find the L over D ratio adalah by using the interpolation daripada table 7.1 table. So, table 7.2 punya table adalah interpolation of rho coming from the table 7.1. Okay. For table 7.3 shows the value of the span to the depth ratio for simply supported beam / slab in accordance to the interpolate of rho value. Okay. So maksudnya kat sini figure 7.2 kita boleh dapat daripada graph. Okay, jadi saya tunjuk. Lagi satu adalah cara kita menggunakan interpolation of the row value. So, this is the graph that I told you before, which is the graph of the basic span effective ratio for the simply supported beam. So, maksudnya kita dah calculate nilai row kat sini. So, we know that we are given the strength of the, ataupun grade of the concrete. So, kita boleh cari dia punya span effective depth. So, L over D. Kita boleh cari lah. Let's say kita punya tu adalah 1.2 dan kita punya grade concrete adalah 40. So, it's around 17, I guess. Here. Okay. So, ini adalah satu kaedah yang pertama, which is we are using this figure. Okay. Next is by using the table. This table is to determine the basic span effective span ratio. So, kita kena tahulah nilai apa jenis kita punya structure tu. Simply supported beam ke, ataupun interior span of the beam ke. So, this is the nilai K yang kita perlukan. Okay. And this is the, depends on the row yang kita dah kira. So, row tadi adalah 100 AS required divide by BD. Okay. So, this is the table 7.1. So, 7.2 benda yang sama juga. Nilai L over D. Okay. Basic ratio of span over effective depth. Okay. I think mistake here. This is not the effective span. This is the effective depth. Okay. Okay. So, ni sama juga. Cuma dia dah interpolatekan lagi. Okay. Dia interpolatekan lagi for the value of row. Okay. 7.2 dan table 7.3. So, basic ratio of the span effective depth for simply supported beam / slab. Okay. So, ini adalah cara kita nak tentukan nilai L over D. Okay. Selepas itu, okay. Then, kita kena cari, okay, kita dah cari dia punya L over K dan kita pun boleh cari nilai K1 dia. K1 dia kita dapat daripada table. Okay, daripada table 7.1. Depends on dia punya condition of the structure. Sama ada dia interior span ataupun dia adalah simply supported. So, dia ada value dia. Okay. Tapi, for the flange beam, we need to calculate by using this equation. So, otherwise, K1 is equal to 1. Okay. So, the next step is, we need to calculate the modification factor 2, K2. Bila mana beam span melebihi 7 meter. Ni dah correct kan? Tapi tak sama. Tak boleh buat kat sini. So, bila beam span itu melebihi 7 meter, so we need to calculate the value of K2 by using this equation. So, otherwise, K2 is 1. Okay. So, determine the third one is determine the modification of K3 for steel. So, we need to calculate the K3. K3 adalah AS provided divided by AS required. Okay. Then we need to check the L over D ratio times with K1, K2, K3 yang kita dah kira, yang kita dah cari. Mestilah lebih besar daripada nilai actual L over D. Okay. If so, the check is complete. If not, increase the area of the tension reinforcement if provided. Okay, so this is a step yang saya dah summarizekan, which is the first step is calculate the ratio of L over D. So this is how to calculate the row. Okay, then step 2, step 3, step 4. Okay, step 2 is to calculate the K1 by using this table. Okay, step 2. K2, if the beam span is greater than 7 meters, so we need to calculate by using the formula. Otherwise, K2 is equal to 1. Okay. The step 3, at the step 4, the last step is K3, modifications for steel. So, by using this equation. So, after we calculate this item, we found out, we determine the K1, K2, K3, L over D. So we can calculate the this value. L over D times K1 times K2 times K3 should be greater than the actual L over D. Okay? Okay, for the first example, this is a simply supported regular rectangular beam, length of 6 meter, and this provided by this figure shows. Given tension reinforcement is AS provided is 2592, AS required 2497, FYK, FCK. Check the deflection of the beam. Okay. First kali, kita akan check, kita kena kira dia punya rho, which is 100 AS required divided by BD. Okay, we calculate the this one, and by using this one, we can know the basic span effective depth ratio. Okay, so kita dah tahu dia punya FCK is 30. So kita guna kat graph tu dan kita tarik, dia akan dapat 14. You guys can do it by yourself ataupun kita guna table 7.3. Okay, so kita akan dapat ratio 14. Step 2. Okay, this is simply supported. Dia dah mention awal-awal dia adalah simply supported. So K1 is 1. So step 3, kita kena kira AS provided bagi dengan AS required. So kita dengan dapat 1.04. Okay. Then kita check L over D times K1, K2, K3. Okay. K2 tadi dia punya span adalah 6 meter. Dia punya length adalah 6 meter. So not greater than 7 meter. So K2 dia pakai 1 value-nya. So kita akan dapat 14.56. So actual L over D kita akan dapat 11 ni. So that's mean our allowable upper limit is greater than the actual deflection. So this structure, this beam is okay in term of deflection. Okay, so for the example 2 also juga sama juga, but this one is the continuous concrete beam. Dia dah cakap kat sini adalah interior span. Dia ada grade concrete 10 meter. So maksudnya dia akan ada K2. Dia akan ada K2 kat sini. Okay. So sini kita boleh kira dia punya nilai. Dia punya L over D dia berapa. Okay. So this one, sebab dia dah kata interior span for continuous beam. So K1 is equal to 1.5. So you refer table ni, you akan nampak benda ni sebagai 1.5. So step 3, sebab dia punya span over than 7 meter, dia kira. Okay, so less than 1. Okay, this is 0.7. So kita kira K3. So by using this value, we can check the L over D times with K1, K2, K3. So we got, yes, greater than the actual L over D. So the allowable upper limit is greater than the actual deflection method. So it's okay. So the deflection is in satisfactory. So I guess this topic is much more easier because we just referred it to the table and understood the problem given. So I leave it to you guys to try to find out this problem and solve it by yourself. Okay, thank you. Check it out. Assalamualaikum.